Hmm. Trigonometry, Chapter 7, Applications of Trigonometry Vectors, Section 2, The Law of Cosines, Video 3, The Law of Cosines Example 2. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Excuse me. In the previous video, we saw a surveying application using the law of cosines. In this video, we will solve a triangle using the law of cosines. For example, solve triangle ABC if A equals 42.3 degrees, B equals 12.9 meters, and C equals 15.4 meters. Remember, we're going to find all the remaining sides and angles of this triangle. Answer. Notice we have the values of two sides in the included angle, SAS. This is precisely the information needed to use the law of cosines. The law of sines would not be applicable at this juncture. We have no complete angle side pair. We're missing side A, we're missing angle B, and we're missing angle C. The law of cosines yields A squared equals 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine of 42.3 degrees. This can be set up either using the ABC version, or rather an ABC version of the law of cosines, or the generic version that focuses on the relationship between the sides and the angle. Specifically for angle A, 42.3 degrees, the square of the opposite side, A, is equal to the sum of the squares of the adjacent sides minus 2 times the product of the adjacent sides times cosine of the angle in between. Now we're going to solve this and then use a calculator. So we're going to square root both sides first. And then I highly recommend getting proficient at putting large expressions like this in your calculator. If you're the type of person that does 12.9 squared, writes it down, plus 15.4 squared, writes it down, minus 2 times all this, writes it down, and then writes down little bits and pieces, there's two problems with that. Number one, the more you write things down, the more opportunity you have to write them down incorrectly. And number two, sometimes when you write something down, it's an approximate value, especially when you do cosine of 42.3 degrees. You want to avoid doing arithmetic with approximate values because that error can be compounded. By the time you get to the end, your answer may be too incorrect. So my advice is do not round anything until the last possible moment. Wait till the very end to use a calculator and then put it all in at once. Now, if you do use a calculator on this one correctly, you should get approximately 10.5 meters. And now we have side A. But we're not done. We're solving the triangle. We still have two angles to go. Notice we now have a complete angle side pair, the A's. As such, we can now use the law of sines to find either angle B or angle C. But which should we find next? There's actually a right answer to that. Recall that when we use the law of sines to find an angle, we also have to consider the supplement of the angle found after using inverse sine. That's because the range of inverse sine will never give us an angle larger than 90 degrees, but our triangle might have an angle larger than 90 degrees. So we have to consider the supplement of the angle that inverse sine gives us. However, we can't avoid all that as long as we don't find the largest angle in the triangle next. That's the only one that can be obtuse, and therefore the only one where we would have to consider the supplement of whatever inverse sine gives us. So as a consequence, when using the law of sines to find one of two missing angles, always find the smaller angle first. It cannot be obtuse, and hence when we use inverse sine, there is no need to consider the supplement. Since the smaller angle is always opposite the shorter side, we choose which angle to find, B or C, based on whichever side is shorter, B or C. Since B is less than C, we use the law of sines to find angle B. Using A's and B's, we set up sine of 42.3 degrees over 10.5 equals sine of B over 12.9. I do want to point out that 10.5 is an approximate value, and I recommend avoiding using approximate values when calculating subsequent values, but in this case, we have no choice if we're going to use the law of sines. So we're going to multiply both sides by 12.9. That'll put the 12.9 on the top of the fraction on the left. And then we'll take inverse sine of both sides to get angle B. And then we'll use a calculator, and we'll get that B is approximately 55.8 degrees. And now that we have angle B, we can find angle C by doing 180 degrees minus 42.3 degrees minus 55.8 degrees and get 81.9 degrees. The completely solved triangle are these six values. And notice that the shortest side, in this case A, is opposite the smallest angle. The longest side is opposite the largest angle. It's always a good idea to check this at the end. If that's not the case, that's a sign that something went wrong. Now you try. Pause the video and try the following. Solve the triangle, round to the nearest whole number. Here's your fair warning if you haven't paused the video to try the problem yet. Solution in 3, 2, and 1. Using the law of cosines, we can find side B. Here's the setup. And we get B is approximately 88 to the nearest whole number. And then you use the law of sines to find the smaller angle. The smaller angle is A because it's opposite the shorter side. And so sine of 55 degrees over 88 equals sine of A over, shoot, that should say, oh, we got a slight problem. Pause video. Did you catch that error? When I'd set up the law of sines, I had sine of 55 degrees over 88, which was side B. So that was correct. But I had sine of A over 100. Should have been sine of A over 90. And then I fixed the what follows. If we solve that for A, we get 57 degrees, and then C ends up being about 68 degrees. You'll notice that it doesn't matter how good you are or how careful you are, it is easy to make a very casual yet careless mistake when setting up the law of sines, setting up the law of cosines, etc., etc. And again, in case you missed it, originally there was 100 down here, but 100 is not opposite angle A. 90 is opposite of angle A. I have fixed it, and the rest of the solution is correct. But this goes to show you it doesn't matter how good you are, how many degrees in math you have, how many years you've taught math, how many videos you've made on YouTube, over 1,000. If you're not careful, you will make mistakes. And if I make mistakes that casually, imagine for you as my dogs start barking.